Hello class, my name is Arya Airpula, and today I'll be teaching you what is a robot, exploring the machines that make sense, think, and act in our modern world. Welcome to Robotics! Welcome to 7th grade Robotics. Throughout this course, you will transform from technology consumers into creators and engineers. We will design, code, and test autonomous systems while solving real-world challenges. Connecting prior knowledge. Think back to a simple machine or coding project from earlier grades, like Scratch or Lego builds. Today we lay the foundation by defining what makes a robot special compared to traditional technology. So, take a few seconds and think. Get a gist of what things you've used and try to remember if you've tried to make a project like this or if it's your first time. And break down the words if you don't understand, like creators and engineers. An engineer is when people create stuff, and then today you'll be designing, coding, and testing. So, today's learning objective: define a robot. To define a robot, explain the exact criteria that distinguishes a true robot from a non-robotic machine. So, next you identify 4 core parts. Recognize the controller sensors, actuators, and power sources in robotics hardware. Then, master the cycle. Understand the trace, sense, think, act cycle in real-world scenarios. So you define the robot, then identify 4 core parts, then you master the cycle. Try repeating that on your own. So, once you understand this, try to remember a time where you had to follow these steps. If not, it's okay. We'll try to do that today. Warm up. Machine or robot? Look at the image on the right. Take a few seconds to look at it. Okay. The NASA Mars rover explores distant planet millions of miles, meaning that NASA sends different rovers to different planets to explore how land is. While a kitchen blender sits on the countertop, meaning that a daily item is sitting on the countertop. Both perform tasks using electricity and motors. But why is one called a robot while the other is called an appliance? Take a few minutes to figure that out. Discussion question: what single ability makes a Mars rover truly robotic? So, to explain this, it's truly called robotic because the amount of parts it has and its tasks. It has variety of parts, such as motor, belts, and so on. But in a kitchen appliance, all it does is just maybe grind food and stuff. So you can't really debate that is robotic. Both use electricity and motors, which is true. But a Mars rover truly shows that it uses motors, and it can actually do stuff like sensing stuff. Sensing is also a big part of robotics, using a camera. And it also uses intake and really gives outtake. So, what is robotics? Mechanical engineering. Designing physical structures, gears, chassis, and arms that withstand forces. For example, if you can see, once you see the picture, you might be able to see small parts of the robot sticking out. That's mechanical engineering. That's their job to do that. Electrical engineering, connecting power supplies, microcontrollers, wires, and electronic sensors. My bad. That means that they are the ones connecting the electricity power into the actual robot. and it shows us that the sensors are being connected with the electronics, wires, and microcontrollers, which is also a big part of robotics. Then, this is the brain of robotics, computer science, writing algorithms and logic that command the robot to make intelligent decisions. Each of these majors or studies have unique structures and unique ideas. Like, all of these combine to create a single project, which is really fascinating. Next, defining a robot. An autonomous system. A robot is a programmable machine capable of gathering information from its surrounding, processing with data, and carrying out physical actions automatically. Without the ability to sense environmental changes or make logical decisions, a machine cannot be classified as a true robot. This is a core part, so I'm going to repeat that again, but slowly so you guys understand. An autonomous system. A robot is a programmable machine capable of gathering information from its surroundings, processing with data, and carrying out physical actions automatically. Without the ability to sense environmental changes or make logical decisions, a machine cannot be classified as a true robot. Robot versus standard machine. Features. Decision making. Follows fixed mechanical switches on and off. And then a robot makes decisions with a microprocessor program. So, a standard machine like a blender follows fixed mechanical switches, while a robot makes decisions with microsensors. Then environmental sensing. Does not react to environmental changes. A robot uses sensors, distance, light, touch to adapt. Adapt meaning that it can be able to live and be near in its surrounding environment. Then autonomy. Requires 100% direct human operation for a standard machine. For a robot, operates autonomously or semi-autonomously, meaning half can be made by human controlled and the other half is by itself. Then, flexibility. Can only perform one fixed task at a time, standard machine. And then, can be programmed for new tasks, a robot. Where are robots used? Exploring real-world robotics, transforming everyday life in science. Homes and hospitals. Smart homes. Autonomous vacuum cleaner, maps rooms using infrared litters to clean floors without hitting furniture. For smart homes. Modern healthcare. Robotic surgical assistants allow surgeons to execute micro-precision operations with minimal incision sizes. Robots also disinfect hospital halls using ultraviolet light and delivering medicine to patient rooms. Factories and farms. Industrial manufacturing. Heavy robotic arms weld car frames, assemble microchips, and package goods 24 hours a day with millimeter precision. They handle hazardous materials safely, protecting human workers from industrial injuries. Let me repeat that again so you guys understand. Industrial manufacturing. Heavy robotic arms, weld car frames, assemble microchips, and package goods 24 hours a day with millimeters. They handle hazardous materials safely, protecting human workers from industrial injuries. Agriculture automation. Autonomous trackers use GPS to plant seeds in perfectly straight lines, optimizing farmland usage. Robotics harvesters use computer vision cameras to check ripeness before plucking fruits without bruising them. Space and disaster response. Exploring extreme environments. Space exploration. Planetary rovers navigate terrain on Mars. Terrain meaning rocky surfaces. Collecting rock samples where humans cannot survive. Disaster relief. Aerial drones and treaded robots search through earthquake rubble, pinpointing survivors, measuring gas levels safely. Why are robots important? The 3 Ds of automation. Robotics place humans in tasks that are dull, meaning repetitive, dirty, unsanitary, dangerous, toxic, and hazardous. Robots perform ideal actions millions of times without fatigue or loss of accuracy. Extreme reach. Robots venture into deep oceans, active volcanoes, radiation zones, and deep space. Autonomy of a robot. Introduction of the 4 main functional hardware components. The microprocessor, such as VEX, Brain, Arduino, or Microbit, that runs the code. It receives data from sensors, processes algorithms, and sends commands to motors, which is the brain, which people use computer science to code. Then sensors, hardware devices that measure physical properties of environments. Example, ultrasonic sensor, distance sensors, bumper touch switches, optimal color sensors, and gyroscopes. Actuator muscles, mechanisms,